Welcome, Michael here. Friday evening. I thought it might be interesting to visit Dr. Linda Green's 12-hour tutorial on basic calculus. And I thought I might provide some visuals by also teaching a little bit about Grasshopper too. So let's take a look. Basically, I have the link in here if you want it as a file. I think we're at G2 day 17, more or less. Guess better save it in case anything crashes. And basically, it starts out by just like factoring and simplifying equations. So here's an equation here, but what I want to show is from this graph that even though I'm not doing the calculus to make this a simpler equation, it's the exact same graph from 3 times x plus 6 all over x squared plus 4x plus 4. I'll try into getting the correct equation notation here so I can use some maths and things like that. But basically, after that function is reduced, it's still nice to visualize it. So what I've done is taken that simpler function, or for the sake of just whatever, feeling like you're a little more mathy, let's take the more complex equation and run it through its function evaluation between 0 and 5. That's all I'm doing, and it is showing the evaluation of where at whatever point on x y's count will be on the far right. And I also ran it through the derivative, which of course provides the slope at every time. And you can see that it's always negative because this curve always seems to be dropping down. There's a little jiggy going on here because it's not a continuous function. It really does kind of jazz up. And you can see it from here. What I've done is I decided instead of just using that function and happy with the graphing tools, I would go in and set the function from negative 10 to 10, put that through a range, from negative 10 to 10, hit 100 value for its steps, and then take it through the function evaluated at x and at y. And of course, there's this asymptote in here, so it doesn't solve right in the middle. You get a bigger range in the quick graph of what's happening, but really our graph is really what's happening as it's coming a little closer to here. So this quick graph is kind of wild. I guess it doesn't have to be that wild, but that's what it is, and I threw a line through it. I also thought it's nice to evaluate the integral, which is not coming up anything, and it's defaulting, because as I shorten that, you'll see as I move away from the asymptote, now I can calculate from whatever I want, from this number to this number, the area under this graph, and there's your area under the graph. So it really visualizes for you what integrals do and what differentiation will do for you. Finding the slope, and the other one will find you the area under the graph. Of course, it functions this time. You can see that we have this nice little symbol of this graph going up, and it's kind of skewed it, so it makes it for a more interesting graph than what we're actually seeing in the Rhino interface. But that's it. I'm going to run through this presentation and just slowly understand, remind myself of all the wonders of calculus, and I'm going to do that through just some simple notations. You can see that really jazzy loopiness going on here, which is fine. I can deal with that as an interpolated curve. Obviously, it's got to ditch around. It makes for a fairly interesting form if you took that curve and you actually baked it. Because remember, you can always build geometries from these things. So I will go into here, into the curve, and if I remember how to bake, oh, I just flattened it. Oh my goodness, I've forgotten how to bake so quickly. Let me see if I can't remember where it was. Grafting, simplify, reverse, sort. This is my curve. Oh, there it is. You have to hit the middle one. It's been a while. I've been like 2 days since I was playing with this, and this is what happened. So I'm just going to bake that curve and jump back into the Rhino window, take all views, and probably take that curve through a rotation, which might be nice. Or I could just grab that curve and lift it, loft it up with a tab here. And you can see that we have this pretty interesting geometry that I can go into shaded. There we go. We produced a nice little piece of geometry from very simple graphs, simplified or factoring out of this equation to this equation, and we end up getting this form. So hopefully you understand what I'm doing. I'm trying to provide the visual connection that I found a disconnect in the late 80s and early 90s in my schooling, but now I'm able to really get an understanding of the basic calculus and what that might mean for the designer. So 5 minutes. Thanks for watching.